In this video, I am going to discuss about drilling fluids or which is also known as drilling muds. Broadly similar thing, drilling fluids and drilling muds. So I'll be discussing about typical thing which will not be available anywhere, because this compilation is not only from different books or published papers but from different journals as well as online, but my own understanding also I have kept in this. So please stay tuned. So first of all, drilling operation. What is the use of drilling fluids in drilling operation? Of course, somehow it has certain role in improving the overall quality of drilling. That is definitely for sure. But how? There are 5 types of drilling muds. Basically, water based, oil based, both are liquid form, then synthetic based, foam based, and polymer based muds. These 5. Broadly for understanding, if we see the physical states of matter, so liquid type um, drilling muds, that is oil based or water based. Gaseous type means air based. Air plus liquid means foam. Synthetic means what? Which is chemically processed or artificially produced in the lab. That is synthetic. Foam means, of course, I have told, gas plus liquid. And polymers means, you must have seen in organic geochemistry, organic chemistry, several huge chemical bonding is there, called macro molecules. Okay, so these kinds of large molecules are called polymers. Like if we see monomer CH4, but in case of unsaturated type, where carbon plus 4 valency is not satisfied, then it will keep on forming chain. Like that, these polymers are naturally available, which are often used. There are certain polymers used in drilling muds. So ultimately, drilling mud selection is a function of the behavior of the formation to be drilled, because there are different type of formation, maybe shale, sandstone, limestone, where depending upon situation, that's things I will be discussing in this. Now see, there is a formation. Suppose here we can see it is highly porous and permeable. Permeable means porosities are interconnected pore spaces. So what happened? There needs to be maintain certain balance, because formation is also having their own fluid which try to escape when we dug some borehole. Due to this pressure escape, formation fluid tend to come inside the borehole and fill this. Okay, so then what will happen? Drilling will be hampered. So to maintain that balance, we need to artificially inject some fluid, but that fluid must have certain viscosity or certain pressure. So that fluid pressure and formation pressure balance must be maintained. In case of higher formation pressure, we need to we need to add certain materials with that fluid so that it can have high viscosity, high density, so that it can resist this formation flow inside the borehole. Like that, in case of highly porous permeable formation, there is a possibility of caving or borehole collapse at places. So drilling fluid also makes certain wall in the form of mud cake. So this apparent impervious layer protect borehole collapse. Okay. So other than that also there are so many things which we'll be discussing. So please stay tuned. Many types of drilling fluids are used on day-to-day basis. Some wells require different types to be used in different parts of the hole. Suppose for example, in a particular borehole, from above up to 10 or 20 meters we are getting sandstone, then suddenly shale, then limestone appears. So depth wise different rock condition changes. So with reference to that changing condition, accordingly drilling fluid property can also be needed to be changed. Okay, so that sometimes even some types uh, used to be in combination with others. Certain time there it is observed that drilling fluids, more than two types of drilling fluids are mixed together to make a certain type of new drilling fluids or parts. So the various types of fluids generally fall into broad categories. Okay, so main use of drilling muds are versatile. It can enhance viscosity. So viscosifier means the mud which can enhance viscosity. pH modifier. pH means negative logarithm of hydrogen plus H plus ion concentration. These are basic thing. Then fluid base or media. Okay, fluid base means how that fluid will be thicker or thinner. Okay, lost circulation material. Lost circulation means if this is highly permeable or fractured or high intensely deformed, what will happen? The drilling mud will flow along this. It cannot be returned back. That is called lost circulation. And apart from that, density regulator. Drilling mud often used as very well density regulator, because these materials, when it is cutting materials also okay, you are, for example, you are doing core diamond drilling. So when cutting we are getting cylindrical core, but there of course will be some cutting materials as well in the borehole. So those materials will be create disturbances. So it is very much essential to remove those things. So drilling fluid act as a very important media in taking them out. Okay, main functions of removing cuttings: impede wellbore collapse, because this is impeding, no? Sealing permeable formations, preventing gas escaping, avoiding drill overheating. Yes, of course, this is liquid or fluid, whatever it is. When this crushing and grinding take place, crushing grinding effects due to friction during coring, what will happen? The drill bit temperature enhanced, and that is why drill fluids also regulate temperature, because this fluid when come into contact, it will definitely reduce the temperature. So classification wise, liquid based means water based, oil based in two types. Then gas or gas plus liquid mixture, or understand, that is foam, only gas, only water, only air. Okay, so definitely see this viscosity is more for liquid compared to gas. So when gaseous fluids will be required, when formation pressure is very much less than the borehole pressure. So that time I don't need very high viscosity, otherwise formation will be damaged. Okay, when this formation pressure is high, that time to resist that water flowage into the borehole, we need high dense material. So accordingly, depending upon the formation pressure, proper drilling fluids or drilling mud materials are required to be fixed judiciously. So if we see the functions, there are different functions. Most of the things are required to be discussed in brief. For example, at the beginning I have shown suspend, release and remove of well cuttings. Apparently it appears very easy. When I'll discuss, you will understand why I am putting significance on this, because when you will be performing by your own and in the field, there are several times you will be facing different challenges when drilling will stop due to different type of problems, and that time you will be facing real trouble and will be feeling helpless. So to avoid that ambiguity, we must understand the problem. Then only accordingly you can you can you can address that problem and solve the problem. So suspend, release and remove of well cuttings, control formation pressure, seal permeable formations, maintain well bore stability, minimizing formation damage, then cooling lubricant, then transmit hydraulic energy to tools, ensure adequate formation evaluation, control corrosion, facilitate cementing and completion, and minimize impact on environment. Out of all these, most of the times, these six factors are very much essential, very much, all are important, but these five are most frequently observed. Okay. So I'll be discussing in detail little bit. Suspend, release, and you see the thixotropic property means viscosity. Okay, high viscosity automatically it enhance when in static condition. So what happen? Suppose you are drilling a borehole, then when taking up the core, that time for short time that condition is in rest, that time what happened, drilling fluid help in by its thixotropic property, its viscosity automatically increases when static, it keeps the cutting suspended. If it suddenly drilling material that cuttings gets settled down below, it will be very difficult to take them out. That is why drilling this thixotropic property helps the cuttings to be suspended when the mud is not flowing. And when flowing starts, automatically since these are suspended, it is easy to take them out. Next property is drill cuttings that settle can cause. That's what I have discussed. No, if by chance it gets settled down, all the drill cutting materials, what will happen? It will cause breach and fill, which can cause even stucking the pipe and lost circulation of fluid instead of return up. So fluid will not coming back, and borehole drill pipe often can be drill rod can be stuck because these drill cuttings gets settled. So if we not properly utilize that drilling fluid, so it can get stuck. Okay. The next, I will further discuss on specific condition. You will understand. High density fluids may clean holes adequately even with lower annular velocities. Annular velocity is what? Annular velocity means that fluid injection velocity by increasing the buoyancy force acting on cutting. Okay. So annular velocity means fluid injection rate, that drilling fluid can be controlled, regulated. No? So annular velocity is speed of the drilling fluid movement in a column called the annulus in the well. It is commonly measured in feet per minute or meters per minute. High concentration of drill solids are detrimental to drilling efficiency because they increase the mud weight and viscosity, which in turn increases the maintenance cost and increase dilution. So from this we can understand easily that we need to have a balance, neither very less concentration nor very high concentration. For effective solid controls, drilling solids must be removed from mud on the first circulation from the well. If recirculated, cuttings break into smaller pieces and are more difficult to remove. So we need to understand these things. Further, now these are about cutting material removal. Now another important thing is formation pressure control. Because as I have told, if formation pressure increases, mud density should be increased accordingly to balance the pressure to keep borehole stable. Unbalanced formation pressure may cause unexpected influx of formation fluids into the well bore, and which lead to a blowout from pressurized formation fluid. Often we might have seen during drilling lot of fluids coming out. That is the condition where formation fluids are in high pressure. So in such condition, what is required? We need to enhance the drilling fluid density, because hydrostatic pressure equal to density of the drilling fluid multiplied by true vertical depth multiplied by gravitational acceleration, of course. So if hydrostatic pressure is very much high or more than equal to the formation pressure, formation fluid will not flow into the well bore. Simple, because formation fluid I am already this by using proper hydrostatic pressure. I can regulate the formation pressure. This formation pressure try to bring the formational fluid into the borehole, and borehole hydrostatic pressure can be maintained by adjusting proper drilling mud fluid, so that can resist formation fluid to come inside the borehole. So the most common weighting materials which can enhance the formational fluid density is barite, often used BaSO4, barium sulfate, and well must be kept under control means no uncontrollable flow of the formation fluid into the wellbore. So regulation is important. Neither it has to be very high, that formational fluid pressure, nor it should be very low. That means my drilling fluid pressure must be regulated properly. If it is very high, if I by chance I am making very dense, that what will happen? It will create intense pressure on formation. So formation eventually will be fractured. Okay. So well must be kept always under control. If formation pressures are very low in the borehole, then I don't require very high dense material in drilling mud. So in that cases, air, gas, mist, or stiff foam, or low density mud, often oil based, these can be used. Mud density should be limited to minimum necessary for well control and well bore stability. Very high density mud may create fracture in the formation. So eventually will not be getting proper recovery. Another important thing is sealing of permeable formations. When formations are having very much porosity permeability in the form of either secondary fractures or normal primarily alteration, or because of just natural characteristics, intensely porous permeable formation, there often we can see this kind of problem where if even within that formation fluid pressure is high, then we cannot regulate. Huge water will start coming, formational fluid. So to regulate that, we need some impervious wall, artificially creation of impervious wall. So by using proper drilling mud, proper dense material, we can make a wall. This is called filter cake or mud cake, which can act as a wall, which can further minimize the formation fluid into the borehole. So mud column pressure must exceed formation pressure so that mud filtrate invades permeable formations to up to certain level, and a filter cake of mud solids is deposited on wellbore wall. Problems can occur in case of thick filter cake. So balance should be maintained. Again, I am talking about that, because if it is very high dense materials is used, then thickness of the cake, filter cake, will not be optimum. It will even become very high, which cause tight hole condition, poor log quality, stuck pipe, lost circulation, and formational damage. In high permeable formations with large pore throats, well mud may invade the formation. Okay. For effectiveness, bridging agents like calcium carbonate and ground cellulose, these are used to block large openings. Okay. Whole mud may invade the formations, because whenever permeability is very high, that time these kinds of things are required. And by chance we are making this out of control, we are mixing more and more, what will happen? Cake density will be more, that cake thickness will become more, it will stuck the pipe again. So again balance must be maintained. Okay. A number of additives can improve the filter cake. It is often known that bentonite, natural or synthetic polymers, asphalt, then gilstone, okay, gilsonite. These are important. Then Another important property is about borehole borewell stability, because wellbore instability means sloughing formations which can cause tight hole conditions, breaches and fill on trips. Same symptoms indicate hole cleaning problems. So wellbore instability often cause even stacking. Okay. On the contrary, wellbore stability means hole maintains size and cylindrical shape because no collapse. If the hole is enlarged, it becomes weak and difficult to stabilize. And problems such as low annular velocities, poor hole cleaning may result. Eventually, even borehole may that drill rod can be stuck again. So these are the different issues. Okay. So they see here are the importance of drilling fluids everywhere we can understand. For example, in sandy or sandstone rich formation, hole enlargement often can occur from mechanical actions like hydraulic forces, nozzle velocities. So formation damage is reduced by conservative hydraulic system. A good quality filter cake containing bentonite is known to limit borehole enlargement in case of sandstones. Whereas in case of shale, when using water-based muds, chemical differences can cause interactions between mud and shale. Mud means drilling mud. That lead to weakening of the native rock shale, and highly fractured dry brittle shells can be extremely unstable, leading to mechanical problems. So when condition is like shale or schistose rock, highly fragmented along with very much sandy materials without cement, loose sand grains, their problem is challenging because this is mixed. So judiciously drilling fluid must be utilized in those circumstances. Various chemical inhibitors can control mud shale interactions like calcium, potassium, salt polymer, asphalt, glycols, oil-based water-sensitive formations. Okay. So another thing is oil or synthetic oil-based drilling fluids can be used to drill water-sensitive shales. Sometimes in areas with difficult drilling conditions, some shales are often water-sensitive. It can be showing volume changes on interaction with water. So in those cases, oil-based drilling fluids are used. However, oil-based are relatively costlier. I'll show. To add inhibition, emulsified brine phase calcium chloride drilling fluids are used. Okay. Next, minimizing the formation damage. Yes, all are related to each other. Last slide is there is a link every time. So mud or drill solids invade the formation matrix, reducing porosity. And when swelling of formation clays within the reservoir reduce permeability. So these are the natural problem. Okay. Always drilling mud should be utilized judiciously because precipitation of solids due to mixing of mud filtrate and the formation fluids resulting in precipitation of insoluble salts, and that mud filtrate and formation fluids form an emulsion reducing the reservoir porosity. These are mostly problems encountered in oil because porosity permeability matters in oil exploration. Specifically designed drilling drill in fluids or workover and completion of fluid minimize the formation damage. Now types of drilling fluids, this is very important. As I have told at the beginning, fundamentally 5 types are based on phase: air only, air, water, water only. These also are main fluid actually. Now different additives are mixed with that main base fluids. Okay. I'll show what is the, there is a misunderstanding. Drilling muds, drilling fluids, these are same thing, but overall material needs to be understood. Only air can also act as drilling mud or drilling fluid. Air water mixture, often called as foam, that is also used as drilling fluid. Water only also. Now, as and when required, other things are mixed along with this additive. Okay, so water-based, oil-based, synthetic-based, foam-based, and polymer-based are 5 main fundamental things. For example, different company have different brands, but most of the times, for example, in case of oil sector, there are several uh, drilling muds are used by Halliburton and Schlumberger's. For example, for water-based mud, Aquapack, Aquaclear; for oil-based, Borrowed, MI, Swaco. Okay, these are the difference. You can pause this video and see for your information if you are interested in. But for other way, nowadays this is very much getting popularity. AMC CR650. Okay, this is often in Africa also it is used, and most of the worldwide nowadays for mineral exploration it is used. AMC CR650 means full form is Australian Mud Company. Their CR650 is very high quality powdered polymer. Polymer means I have told you, large molecule. The same sub molecules will be keep on attaching and create huge molecule. Okay, so this polymer primarily used as a viscosifier. Large polymer means high viscosity. This much you must understand. High viscosity means it can resist flow. Okay, so high polymer material cannot flow very easily. Okay, so viscosifier in water-based drilling fluids is used, which enhances the viscosity, providing better hole cleaning and suspension. But very much there is a certain composition. It is high molecular weight powdered polymer derived from natural polysaccharides. So proper dose must be understood. Otherwise, it can create blunder. What about the key features? Effective in both freshwater and saltwater drilling fluids. This particular AMC CR650 exhibit excellent thermal stability and tolerance to a wide range of pH levels, provide superior hole cleaning properties, reducing the risk of stuck pipe and other drilling problems. Yes, there is a problem. It of course reduce the risk of stuck pipe, but if we are not utilizing according to the prescribed dose, it can also give opposite scenario. Compatible with various additives commonly used in drilling fluid system. This particular drilling fluid material. But dose sensitivity, again I am talking about, like many drilling fluids additives, the effectiveness of this particular AMC CR650 can be dosage sensitive. In that particular package itself, formation wise dose are specified. So drillers should follow that. Using too little may not achieve the desired rheological property or filtration control, while using too much can lead to excessive viscosity and fluid loss. Even it can stuck the drill rod. Okay, so this is the importance of this. Now water I will be talking about in brief, advantage, disadvantages and details. What, for example, let us start with water based mud, WBM. So water based means base fluid is water. Viscosifier is mostly viscosifier means the material which are added with water to enhance viscosity. Okay, so bentonite clay, xanthan gum, carboxy methyl cellulose, these are the important viscosifier. As I have told, this is polysaccharide in case of AMC6 CR650. Here viscosifier means bentonite clay, xanthan gums and carboxymethyl. Now fluid loss control. Fluid loss control is controlled by starches, lignites, different polymers. Okay. Shale inhibitors, potassium chloride, potassium carbonate. These can control cell inhibition. It can control borehole collapse. Okay, so weighing agents, barite, calcium carbonate, alkalinity control, by sodium hydroxide lime emulsifier is surfactants used in special application. So advantage: environmentally friendly, economical, readily available, suitable for drilling through water sensitive formations. And what about the disadvantages? Limited temperature and pressure stability can cause formation damage in some types of rock formation, susceptible to contamination from shale swelling and salt dissolution. So each of the fluid is having certain advantages, disadvantages. So based on the formation condition, we need to choose. Now oil based, you see, base fluid means diesel, mineral oil, synthetic oil, some kinds of oil instead of water. Within that, some emulsifier need to be added, like soap, secondary emulsifiers. Then wetting agent means some asphaltic material, resins, not water. And weighing agent means which can enhance the density, like barite, calcium carbonate, manganese tetroxide. Okay. And fluid loss control by asphaltic materials, resins, polymers. Okay, this can resist fluid loss. Then cell inhibitors again, organophilic clays, salts, etc. Alkalinity control is by lime, caustic soda, same as we previously discussed. Caustic soda means sodium hydroxide. And now advantages over water. This oil-based mud is superior lubrication and cooling property it is having compared to water-based, and it is effective in stabilizing borehole in reactive shale formations. See, shale inhibitors, organophilic clays, salts, these are used. Okay, whereas in this shale inhibitor, potassium chloride, potassium carbonate. Now disadvantages. Okay, sorry. Another advantage is enhanced penetration rate in some formation. Okay, it can penetrate more, and accordingly it can control formational fluid pressure. Disadvantage means it's of course higher cost compared to water-based mud. In environmental concerns due to oil contents, potential for wellbore stability issues in certain formations. Now that is why third type of fluid materials were introduced, that is synthetic based mud. Synthetic means which can be fabricated artificially. Base fluid is here ester based or synthetic fluids. Emulsifier is synthetic emulsifiers. Weighing agents like barite, calcium carbonate, this can control the density of the fluids. Fluid loss control by resins, polymers. Shale inhibitors are again organophilic clays, salts. Alkalinity control by lime, caustic soda. Antioxidants and corrosion inhibitors. These are special additives, special feature with this. Often the drill pipe may be corroded in certain circumstances. So those things can be avoided here. Combines advantages of both water-based and oil-based mud in case of synthetic one. So it enhanced temperature, pressure stability, low toxicity and environmental impact compared to oil-based muds. Okay. Whereas certainly there is also having certain disadvantages as well. It's higher cost, limited availability in certain regions, environmental concerns due to oil content at some times, potential for compatibility issues with certain formations. These are the small problems. Then apart from that, so far this is synthetic, okay, not polymers. Polymer based is different. Now foam based mud. Foam based means base fluid is water, gas also will be added. Foaming agent means surfactants, foam stabilizers. Gas phase is air, nitrogen, carbon dioxide. Viscosifier is polymers, biopolymers. Weighing agent none or minimal. That means foam based muds will be required in which condition? When formational fluid pressure is very low. Okay, these kinds of condition will be required to introduce foam based muds. Advantages: excellent hole cleaning ability, reduced formation damage due to lower fluid invasion, lightweight which can improve drilling efficiency, and disadvantages means limited applicability in deep drilling operation, because eventually in case of deep drilling formational pressure will be high, so this cannot be used. Higher dense materials will be required in that cases. So often it requires specialized equipment for generation and maintenance, susceptible to gas migration issue in some formations. So these are the disadvantages, but of course advantages are also there. All the types are having certain advantage and disadvantage. So these kinds of comparative study is required, and depending upon the situation specific way you will have to choose. Now at the last but not the least, obviously, the polymer based on mud. Polymer based mud. Basal fluid is water again. As I have discussed that CR650, that is also polymer based. Okay. Viscosifiers is xanthan gum, hydroxyl cellulose, partially hydrolyzed polyacrylamide. There it was used as polysaccharide. Again you see polysaccharides. Okay, this is also polymers. Here polyaccharides. Okay, now polyacrylamide, fluid loss by starches, polymers, cell images, again potassium chloride, organophylic clays, alkalinity control, sodium hydroxide, lime. Weighing agents same as used, barite, calcium carbonate, surfactants and dispersants, special additives here. Okay, now what about the advantages? Okay, here it is effective in stabilizing reactive formations where oil based or what especially water based cannot be used. Reduced fluid loss and filter cake formation. Okay, compatible with various additives for customization. Disadvantages, because of course it can be expensive depending on the polymers used, requires careful control over geological properties, may require additional equipment for mixing and maintenance. So these are basic comparisons. Now you see few photographs I have taken, I have kept. This is drilling fluid flow. Here if it is proper material is there, what will happen? This fluid flow will go back. While going back, that cutting material will also go, but within that, suppose formation is formation pressure is high, that additional fluid also will be mixed and it will create additional pressure. On contrary, if this we are using high dense material fluid, so what will happen? The high dense material, when they will return back, they will resist, even they will go inside these fractures. So formational fluid will be kicked back, it will be going inside these fluids. Okay, and if it is very high the fluid density, it will create further pressure and fracture. Here it is fractured, see, because of high drilling fluids density. And if it is less dense, it will be okay, but if formation pressure high and we are using less dense like air based, what will happen? Formation pressure further then dominate, then it will enhance the fluid output like this. Here you can see drilling fluids are very properly dense material, so it will go inside and eventually close this permeable path, so that it can regulate, it can control the formational fluids. So this is all about the basics. I hope you must have enjoyed. Thank you.